All right. Thank you everyone for joining our day 2 session for this artificial intelligence and machine learning. Yesterday we had a good understanding, at least overview about the AI, different types of AI and everything. Today we will focus more on the ML and we will see a project. We will also understand the Azure cloud environment from our expert trainer, Vamshi. Thank you very much, all of you for joining. I'm very sure all of you are going to get a good value add for the time you are investing. So let us stay focused. If you have any questions, please feel free to ask. You can always drop your questions in the chat box. All of them will be addressed on time. Thank you very much. Vamshi, over to you.
Thank you, sir. Fine. So, hello everyone, and welcome to the day two session of AI/ML, artificial intelligence and machine learning.
Vamshi, your voice is cropping. I can't hear.
So, am I audible now?
Better. Thank you.
Yeah, thank you. All right. So, yesterday we have understood what is AI, what is machine learning, and again, deep learning, data science, and generative AI. I mean, today we'll dive deep into some kind of ML concepts here. So, what is machine learning? And again, I'll also will show you and explain you some kind of project on Azure and again in Python scikit-learn as well. So a linear regression kind of project and a classification project. But before this, let me tell you a few things. Now you need to understand. I mean, so yesterday we have looked at what is traditional computing and machine learning kind of way. Now, the traditional computing, you give some kind of input based on some kind of syntax or some kind of rules. So where we call it as some kind of program, fine. Then you derive some kind of output out of it. But again, the machine learning kind of case is not in that way. So as I told you, you pass some kind of inputs and again the output as well. So you derive some kind of logic out of it. So that means you especially instruct your machine to understand the patterns in the data. So this is what you derive in a machine learning. Now, for example, now before this one, let me at least, I mean, see, have you ever wondered at least, I mean, so why we require a machine learning? Any idea why we require machine learning? Yes. So what do you think? I mean, so why do you require machine learning?
Automate the process.
Okay, so a valid answer, automate the process.
To make some predictions.
Make some projections. Okay, predictions. Fine.
Simulate human behavior.
Okay, fine. So that, fine. All right. Any other answers? All right, so let me explain you this one. Now think of some kind of situation. All right, so where you are not working with ML. Now, right now, I'll tell you some kind of use case studies. Actually, now in real world scenarios, we're actually dealing and working with ML and AI, but we do not know that it is actually ML and AI kind of jobs here. A simple kind of thing, let me explain you something. For example, your product recommendations, or I mean, some kind of recommendation systems which you have in e-commerce portals like Amazon or some other kind of portals here. So when you purchase, now when you purchase some kind of products, right? I mean, so they also recommend you some other kind of products as well. So people who have bought or purchased some kind of products have also bought this kind of products. All right. So let me, I mean, so that is ML actually. But I mean, many of them do not know that it is actually some kind of AI feature or some kind of ML that you are actually performing. All right. Now let me explain you. For example, I told you one kind of topic here. All right. So simple kind of topic. I mean, so it related to any kind of topic. Let us, for example, try to understand in this way. Now, before to ML, what was the situation? So, I mean, in order to learn about that particular concept, so you, I mean, refer so many textbooks or some kind of books, right? For example, or you even visit some kind of library and again, you search for the particular topic using different kinds of books here. You refer different books here. So that was this case, I mean. So that was the situation we had actually. Now, after machine learning, right? So what you can do is machine learning will automate all that kind of process here. You search for something, again, it will give you some kind of content, whatever you're looking for. So, I mean, so using the concept of some kind of search engines. Fine. So this is a simple case study. So why we require some kind of machine learning kind of rules here? Because in normal process, what you do, I mean, so before to machine learning, right? We had to refer some different number of books in order to master some kind of concept or refer to some kind of topic here. But after machine learning came into existence, right? So we can search for something or we can automate that particular searching kind of process here in, like for example, in an easier way. Fine. Now another kind of examples is, so let me also explain you a few other kind of things here. Now, for example, I've given you some kind of large data. All right, so large data. So do you think that it is even manually possible to figure out some kind of predictions or classifications using the manual way? I mean, because see, we have statistics here, you know, some kind of maths here. All right, so you'll be applying some kind of formulas and you will be deriving some kind of outputs here. But do you think that it is possible even in order to work manually? No, right? If you have a sample data with you, then you can easily work with that one. All right. So, for example, you have some kind of sample data. So you can even work in a manual way. Manual way. But again, you have some kind of large data sets with multiple features. Now, what is features? I'll tell you. All right. So features in the sense you can understand it as some kind of columns here in a data set. So you need to be also very well versed with some kind of machine learning terminology here. All right. So I'll also explain you that one. Now, large data sets with multiple features, that means multiple columns here. I mean, so there is no other way you can actually deal with in a manual way here. So you see, record by record, you can't figure it out some kind of thing, or you can't apply some kind of formulas. I mean, so statistical formulas or something, and you can derive the output here. So there should be some kind of automated way, right? So that is where we train some kind of machine. All right. So I mean, our machine learning model using some kind of algorithms. All right. So these algorithms actually work on the concept of some kind of mathematical foundations and statistics here. All right. So that is why we require machine learning. So when we have large kind of data sets or whenever our data problems are very complex in nature, and again, if at all you want to predict some kind of data or classify something or automate some kind of process here, so we require the concept of a machine learning kind of scenario. Now, let me tell you a few things about this. So for example, now yesterday we have understood the concept of machine learning. I'll tell you with some kind of real-time examples. All right. So what is machine learning exactly? Now there are three different kinds of machine learning algorithms here. All right. So three different kinds of machine learning algorithms. So for example, let me even show you. So even you can understand there are three different kinds of machine learning types here, especially supervised machine learning, unsupervised machine learning, and again reinforcement learning. So what are these one? So let us try to understand from a very basic perspective, because yesterday you have understood what is data science. Now in today's session, I'll tell you what is machine learning exactly. So what you do in real world scenarios. I mean, so merely learning some kind of definitions or any such kind of beautiful slides will not give you any concept here. You have to understand the stuff behind this one. So how does this actually work here? Now, basically, there are so though there are three different kinds of machine learning, right? So as I told you, there are three types of ML. Fine. So three types of ML. Now basically we call them as supervised ML, and unsupervised machine learning, and again reinforcement learning. Reinforcement machine learning. Now, supervised learning is where now we exclusively instruct the machine to learn patterns in the data. All right. So we exclusively instruct the machine to follow some kind of rules here. So that means using some kind of algorithmic ways. So we instruct it to learn the patterns in the data. And unsupervised learning is where, so we actually, so we do not, tell the machine. So instead, the machine itself will find out some kind of, okay, so data patterns here. And reinforcement learning is where, so as I told you, it is pure form of AI. So especially some kind of robotics or some kind of industrial machines, so which works on this kind of concept. So we'll be learning it later. Of course, as part of a course, we'll not be learning reinforcement learning because that is pure form of AI. So it requires a lot of other kind of studies here. So basically, as part of your job as well and as part of our course as well. So we'll be concentrating on these two types of machine learning. Though there are three types of machine learning, so any course you take it, so they concentrate heavily onto supervised and unsupervised kind of learning. Now, let me tell you, so let us dive deep into this supervised learning and unsupervised machine learning. Supervised machine learning. Now, what is supervised machine learning? Supervised machine learning, as I told you, is a form of machine learning technique. So where we have some kind of input labels, so input features we call this, all right? And again, some kind of target label or a target label. So for example, here we have labels. Now, what do you mean by this one? What is labels here? So labels is also called as target. All right, is also called as target. That means what you have to classify or what you have to predict. So that is some kind of target here. So which is also called as a label. All right, so label. So let me call it as label. Instead of labels, I'll call it as label. So which is also called as a target. In some, like for example, if you, some people also call this as response variable. Response variable or dependent variable. Dependent variable. Dependent variable. All right. Now again, see, that means see what I'm trying to say is here you know what is your input features. Now, for example, input features. Input features are some kind of columns. All right. So columns here. Columns here. All right. So let me show you some kind of sample data. Then you can understand what is some kind of supervised machine learning. So in supervised machine learning, we do have mainly two different kinds of categories. One is regression and the other one is classification. Now, what is regression? So basically, when the target output is some kind of numeric kind of number, right? So let's say, for example, it could be some kind of price or it could be any other kind of output, which is into some kind of continuous form or some kind of real number. So that means that is the case of a regression. Fine. So that is the case of a regression. Now, on the other hand, what is classification is? Classification is where you actually classify some kind of data. So basically, it's some kind of categorical data. All right. So let me tell you, regression is where the output variable or your label, whatever we call it as a label here, label is a continuous number or a real number. Real number. Now, what are the examples of this regression is? So some kind of prediction. So for example, it could be say, for example, sales prediction. All right. Or it could be some kind of stock market prediction. Stock market prediction. Or it could be, let's say, for example, some kind of housing prices prediction. House prices prediction. Now, in every example you see here, in all of these examples, right? So let me tell you something. Now, sales prediction. So what is sales here? It is some kind of number only, right? Fine. So you have some kind of number here. It could be anything. It could be some kind of retail sales prediction, or it could be some kind of Apple iPhones prediction, or it could be some kind of Samsung Galaxy prediction. All right. So such kind of number. So output is some kind of number here. It could be a continuous number in decimals actually, or it could be some kind of like some kind of real number. And again, if you take the case of stock market as well. So stock market. Now, what you predict here? So how the stock value is changing. For example, if the stock is, increasing or if the stock value is decreasing here. And what is by the end of the intraday trading, right? So what is the stock value? Again, if you look at the output, right? So this is some kind of continuous number itself. And again, housing prices prediction. Now again, housing prices prediction depends upon lot of factors, how the house price is getting changed here. Now it's based on completely on some kind of different factors here. Now let me explain the concept here. So what is regression here? So let's say, for example, for your understanding purposes, I've given you some kind of sample data here. So sample data for predicting house prices using a regression machine learning model. Regression machine learning model. So remember this thing, guys. Regression always has some kind of output variable in a number format. All right. So especially we use regression models to predict something. All right. So predict something. Now, for example, as I told you, so you see some kind of data here in this way. House ID, area in square feet, and number of rooms, and again age in years. So this is the age of the house. All right. So the age of the house in years actually. All right. And again, you have some kind of output variable called as price. So which is also called as label. Let me explain you guys, please. Okay. Now, house ID, area in square feet, number of rooms, and in age in years, all these are called as some kind of features. All right. In machine learning terminology, these are also called as input features, or else these are also called as predictors or independent variables. Independent variables. Now, because see why we call them in such ways. Now, what is your output label? So, output label, it is also called as dependent variable or response variable or target here. Fine, or target. Now, this will be dependent on these kind of factors here. Now, for example, what I mean to say, so what are the goal that you actually do in, regression machine learning model? So given the unknown values of X here, so you can take it any value of X here. For example, it could be area, or it could be number of rooms, or it could be the age of the house in years. All right. So given some kind of unknown kind of value of X here, your regression model should accurately predict the price of the house here. Fine. Now, what happens in machine learning model is, so whatever the data you have it, right? So you feed all this kind of data to your machine learning model. That means you feed input data. Now, what is input data here? So all this, so house ID, area in square feet, number of rooms and age in years. So especially, so out of these 4 columns here, we take this 3 columns into consideration, your input features. So this is what I given you, right? So, what are features here? House ID, area, number of rooms, and again, age here. So all these are your input features. All right. So where you feed this kind of input data to your machine learning model. Then what you do, so what we do in a regression model is we also feed this particular output to our machine learning model. All right, parallelly with our input features here. Then what it does is, so using some kind of machine learning algorithm, you train this particular model. It could be linear regression, or it could be some other kind of SVM, or again, it could be some kind of gradient, like for example, random forest regressor method also, or there are n number of, like for example, other kind of, regression models here. So using some kind of regression model, what you do is you train your machine learning model to identify the patterns in the data. Now again, what we do here is, so for example, now let me show you some kind of small technique here. For example, now let's say, for example, let us take the case of area. So how area is dependent on this one, or let's say, for example, how price is dependent on this particular feature here. So that means what I mean to say is, now I'll tell you with a simple scenario. You might be aware of, like, say, for example, writing something in this way in mathematics, right? So for example, I write something as x equal to y. Now, what do you mean by this one mathematically? X is equal to y. That means can I say that one? So, like for example, x is dependent on y, or x is directly proportional to y. Now, what do you mean by that one? In this kind of cases, right? If x increases, right? If x increases, the value of y also increases here. In the same way, now, for example, what you have to do is, so how is your price getting affected with respect to some kind of feature called as area? All right. Now, for example, let us try to, look at this particular data now. So, for example, you can even, like, for example, let me tell you, you can even draw this particular figure on a, like, for example, graph as well. So, let's say, for example, let us do it. Now, what I'll do it. So, for example, all right. So, this is my price here. All right. So, this is my y axis and this is my price here. Fine. And again, this is some kind of area. And this is some kind of 0. And let's say, for example, I'll make it to 1500. Okay. And this is 2000. And again, this is 2500. And again, this is 3000. So this is in square feet. All right. Now, what are the first kind of point you have? For example, manually, if you figure it out, right? So, for example, so the first observation is 1200 square feet and you have the price of the house as 150. So let me also do this one. So, for example, let's say I have the price of the house as this is $100,000. All right. And again, this is $150,000. And again, let's say, for example, this is $200,000 here. So likewise, your price of the house increases here. Fine. So let's say, for example, it is again 250. And again, this is 300. All right. So this is 300 here. Now, for example, if you manually figure it out, right? So what is that you will be getting? So what is the square? Price of the house for 1200 square feet. It is 150,000 here. All right. So 150,000. So 150,000, for example, for 1200 square feet. So 1200 square feet, something falls in here. So it is this one. Similarly, what you do is you also plot some other kind of data here. So again, 210, 120. All right. So 210, 120 somewhere here you get. And again, 120, 210. So for example, somewhere here you get it this point. And likewise, what you do. So 320 and 250. All right. So it is 320 and again 250. So 320 falls somewhere here and again 250 somewhere here. So you draw some kind of line here. All right. You draw some kind of line here. Now, what we do is, so how your, like, for example, price is getting affected with respect to the area. Now, if you draw some kind of line, right, you see there is some kind of relationship here. So this is called as correlation actually. All right. So there is some kind of relationship here. And what kind of relationship it is? According to the statistical kind of measure. So we call it as some kind of positive relationship. Now, for example, so you can clearly see that I mean, depending upon the area of the, area in square feet, right? So as the area increases, the price of the house also is increasing here. Fine. So the price of the house is also increasing. So likewise, what we do, we first find out what is the relationship between different variables here. Now in statistics, we actually call them as correlation. Correlation. So correlation could be positive, or there could be no correlation at all, or there could be zero correlation at all. So let me even tell you about that. So for example, if it is a positive relationship, right? So your curve something looks in this way. Fine. And this is a perfect positive correlation. Now, if it is any kind of negative correlation, right? The graph actually tends to, come down here. So this is some kind of negative correlation. And if it is no correlation, right? So the graph actually looks something in this way. So there is no correlation at all. Fine. So correlation always varies from -1 to +1. All right. So the value closer to 1 will be considered as a good correlation. That means there is some kind of good relationship between the two variables here. So that means what you can infer from this kind of, scenario. So you can say that at the area increases, so your price of the house is also increasing here. And again, so your model can accurately predict some kind of things here. So likewise, what you do, again, you take different features here into account. So this is, see, when I take only one kind of feature, it is called as a simple linear regression. Now we have learned all these kind of concepts in our childhood days, right? So I'm recollecting all this kind of things here. So what we do here is, so given any unknown values of X, right? So your regression model should accurately predict the price of the house here. So this is what actually we do in a regression model. So how closely the values are correlated here? And again, what are the kind of correlation that two variables, like for example, enjoy here? So how they are accurately predicting this kind of values here? So we will find out using some kind of regression models here. So likewise, you can predict any kind of thing here. So it could be some kind of weather prediction, or it could be stock market prediction, or it could be some kind of sales prediction, or any other kind of prediction. Fine. So this is what is called as a linear regression. For example, regression especially. All right. And one such kind of, important or the most widely used machine learning model is a linear regression. Fine. Then we have something called as classification. So what is classification here? Now, classification is something where we have two objects here. For example, I want to identify what is some kind of mango, and again some kind of, or let me even tell you in this way. I want to identify what is green apple and again guava. Fine. Now both are green in color, right? Fine. So, but again, see, so what we do here is we try to give the features as inputs to our machine learning model. And what it does actually, so based upon the different features, right, it will try to classify the objects here. So, for example, if you consider this particular data, right, so this is some kind of sample data for a classification model in machine learning. Now, how does classification work here? Let me tell you. Now you have some kind of student entities here. So student ID, hours studied, and again attendance in percentage, previous score, and again extra classes. So for example, now one is yes, so that means he has attended the extra classes here. Zero means it is termed as no. That means he has not attended any, he or she has not attended any kind of extra classes or not taken any kind of classes here. And based upon the student's performance, right? So you need to classify, given any kind of random kind of values, right? You need to classify to which category they belong to. So that means, so year one is treated as pass year. That means he has passed the test year, and zero is considered to be not passed or failed year. You need to classify in this way. Or let's say, for example, likewise, now what we do here is, so I want to identify the color of a object here, or I want to identify which is a cat and which is a dog here. Now what you do? You train your machine learning models in order to identify or in order to identify different features here. Now, for example, if you look at the ears of, dog and ears of cat, right? So the ears of dog will be, like, for example, it will be more actually, more in size, I mean to say. All right. So it will be tending downwards actually. Fine. So likewise, what we do, we differentiate different kinds of things here in a classification model. And then we try to find out, so what is that particular, object about? So for example, here the goal is to classify whether a student will pass or fail based on their performance. So study habits and background, for example. All right. Now again, what are the features here? Hours studied, attendance, previous score, and extra classes. And what are the target variable? So this one is the target variable. That means in supervised machine learning model, you clearly know what is your target here. And again, you clearly know what is your input features here or input variables also. All right. So this is a classification kind of model here. Then there is some other kind of, again, what are the machine learning models you can use this for classification is there are a lot of models again. So one such kind of most widely used kind of model is logistic regression, and again decision trees or support vector machines or random forest classifier, or there are some other kind of classification models as well. And again, what is clustering here? So clustering is a type of unsupervised learning. Now, what happens in unsupervised learning is, now here I told you, like for example, in supervised machine learning, right? So you know your target label. But coming to the case of unsupervised, right? So unsupervised machine learning model, we don't know. So what is the target label? So for example, the better example I'll give you in a real world case study. So for example, let us take the case of clustering, customer segmentation kind of model here, customer segmentation. So for example, if you remember, yesterday I've given you some kind of example here. So for example, so cluster one. So what is cluster one is? Cluster one is something, so where, for example, see the customer purchase or is purchasing patterns is into some kind of range actually. So for example, he shops for about 1,000 to, let's say, for example, some kind of $5,000. All right. He might shop in this particular cluster here. Or let's say, for example, the other kind of cluster, what I'll do is, so let me say that, so in between 5,000 to $15,000. All right. Then again, let's say, for example, so the cluster three, so it is more than $20,000, or let's say, for example, $15,000 plus here. All right. Now, given any kind of, like for example, customer, right? I need to classify or I need to cluster him in according to this pattern clusters here. I need to group him based on these clusters here. Now, how would I come to know? So, for example, if you went to some kind of retail store, right? So, can I figure out anything that you would be falling under any of these kind of categories? Only if I have your data, right? So, I can figure it out. Like, for example, what is your, for example, most cluster here, most widely used kind of cluster. See, for example, let us try to understand. You have visited some kind of retail store 5 times in a row, for example, in a month here. All right. Now, each and every time when you visited from kind of retail store, right? So, for example, you have given me some different amounts of sales here. For example, initially you have given me $500. So you have given me $800. You have given me $750 here. And again, let's say, for example, you also have given me $1,000, or let's say, for example, $2,000 here. Now, so let us try to understand. So in this way, $1,500. Now, for example, so if you look at this particular data, right? So about a particular customer, right? So I can understand. So what is his purchasing patterns here? So based upon the past data or based upon the data that I have, right? So I'll be coming to know, so I'll be identifying the different parameters here. What is this kind of, cluster that he can fall into. So most of the times by looking at the data, right? So he has not given me more than $2,000 here. and not less than $500 a year. All right. So, but again, if you look at the kind of sales that I'm having, right? So it almostly says that most of the data falls in between 1,000 to 2,000 a year. All right. So now what I can tell you is, I'll answer your questions, guys. Please, okay. So just wait. So what I can tell is the cluster C, for example, the particular customer X, let's say, for example, his name is X here. So a customer X might fall into this particular category. All right. So that means group one. Group one. So based on this one, right? So now what happens here is I do not know what is my target label here. Even I do not figure out what is my, like, for example, feature. So every variable is a feature here, but I do not have any such kind of label here. That means any kind of target variable. So what I do, I use some kind of machine learning model and I train it. And again, I ask it to identify the patterns in the data. So this is what is unsupervised learning. That means in supervised learning, you exclusively instruct the machine learning model to perform some kind of job here. But here, you actually give some kind of inputs here and you ask the machine learning models to identify the patterns on its own here. So this is called as unsupervised learning. And clustering is one such kind of example of unsupervised kind of learning case here. So for example, you have customer ID, you have annual income in thousands of dollars here, and again, spending score. So that means spending score is where, so they have scored him on a scale of 1 to 100 here. So the more the score, we can say that the more purchase, like for example, is likely to purchase something. All right. And again, the customer age in years actually. Now, what is the goal here? The above data can be used to cluster customers based on shopping behavior, which is a classic unsupervised learning kind of task here. So what are the features here? Annual income, spending score, and again, age. So there is no target label since clustering is unsupervised here because you do not know what is like what kind of products you will be purchasing and what kind of sales he will be giving me. All right. So that is why you do not know a clear case of output here. So you might fall in any of these clusters here, any of the groups that you have classified here. All right. So, what you can do here is, so you can use this data to segment customers into groups. That means, for example, low income or low spenders, high income or high spenders, likewise. Or you can improve marketing strategies based on a group behavior. So what you can do is, so for example, if you try to launch any kind of new product in the market, right? When a retailer, okay. So they can figure it out. So which of the customers might fall into, which of the customer segments can give sales here. So because see how they come to a conclusion is now how many of the customers are falling into this particular group here. So cluster one, and again how many of the like for example customers are falling into this particular cluster two. And again how many of the customers are again comes under this cluster three here. So now for example understand that in cluster you have almost, or let us take for example some kind of random 100 customers here. So what I came to find out is so you have almost all 40 customers here. Fine. So let's say, for example, you have, let's say, for example, we have some kind of, I can say 30 customers here. And again, we have, okay, so I can even tell you, fine, in this way. So for example, we have only 20 customers here, all right, 20 customers. Now, for example, so what I can come to a conclusion is the cluster two and cluster one kind of people can give me more number of sales here. All right. So out of these two clusters, right, the customers are more likely to purchase some kind of product if any new product is launched in the market. Now, how much sales they will be giving me, that I do not know again. Okay, so but again, I can come to a conclusion. These particular customers can give me some kind of sales here. All right, how much sales, that is later point of view. All right, so it depends upon the individuals. Like for example, spending behavior here. So some people might be spending more, some people might be spending less here. All right, so likewise, fine. But again, what I can come to a conclusion is so cluster one and cluster two kind of customers can purchase or most likely to purchase some kind of products here. So this is what I can come to a conclusion. And again, based upon this mechanism, right, the retail companies would give them some kind of sales here. Sales here. What do you mean by this one? So for example, you might have seen some kind of 60% off, 80% off, or 50% off, this kind of sales here. All right. So now based upon this sales patterns, right, or this kind of models, right, so they would be giving some kind of sales here. All right. Now, anyways, for example, I do have least number of customers into this particular category. So these are some kind of high spenders here. Now, probably, let me tell you something. So these customers would purchase some kind of product here. Most probably, I do not say that. When they visit any kind of retail store, compulsorily or mandatorily they'll be giving me $15,000 plus year. But again, some kind of product they'll be purchasing. I can get sure short. I can tell you that. I mean, so they can purchase some kind of year. But again, these people are more likely to purchase if I, like for example, enforce any kind of discounts on the products, or again, if I give any kind of discounted sales on the items here. So this is how a retail organizations come to a conclusion actually. Fine. So this is about clustering kind of mechanism. So this is one of the machine learning kind of case studies where you do not have any kind of target label, but yet the machine learning model will identify the patterns in the data and it will figure it out. So the task for you. So this is what is called as clustering, guys. So finally, a machine learning model, as I told you, is divided into three categories here: supervised learning, unsupervised learning, and again, reinforcement learning. So what is supervised learning? Model training with labeled data. That means you train the model with a labeled data. Now you people know, right? So what is a label? So it's a target, kind of variable here. Now, what is unsupervised learning? Model training with unlabeled data. So you do not know what is some kind of labels here. You do not know the target or the output here. But yet, so you instruct the machine to find out some kind of patterns in the data and cluster the data here. Now, reinforcement learning is heavily used. So it is one of the basic forms of AI. So as I told you, so what are the examples of this one is robotics. And again, let's say, for example, some kind of self-driving cars here. So for example, Tesla cars here. Now, before they actually launch that product into the market, right, Tesla car, so they actually test it in various parameters here. Now, for example, let's understand that you have tested some, for example, you have manufactured that car. Okay, Tesla has manufactured that car. So even before it releases that particular car into the market, right, they have to train them on a lot of parameters, guys. So because it has to identify the objects on the road. So when it is navigating, and again, when I instruct it to take left, right, it has to take left here. So instead, if it is taking straight or taking right, so that is some kind of failure. So we penalize that kind of model here. All right. So likewise, I instruct the robot to perform a particular task here. And again, let me tell you, so what happens here is, so we speak in terms of agent and environment in reinforcement learning, right? So what we do, we speak in terms of agent and environment. Now, what is an agent and what is an environment here? So agent is just like some kind of robot. All right. So it could be some kind of self-driving car like Tesla car also. Tesla car also. Right. Now, what is the environment here? If it is a robot, right? So now in which environment you are, like for example, including it. All right. So in which environment you are training it. So for example, let me tell you a simple use case study. Now I want my robot to bring some cup of coffee to me. Now I train it in my kitchen. So I train it in the entire environment here in my kitchen environment. All right. So for example, so give it some kind of different objects here. I instruct different objects to it actually. All right. So it will learn from different kinds of objects here. What is that object here? And then it will even perform the job here. All right. So because I even feed that particular data, manually actually. All right. So instructions, all right. So then it can perform that particular task. Now, for example, the same kind of robot, when it got trained in a, like for example, kitchen environment, right? I can't expect it to perform some other kind of task which it has not been trained on. All right. So that is called as an, like for example, AI agent. So whatever you're training for that, right, it can only give you that particular solution. So similarly, now you can see, like for example, different kinds of bots or some kind of, like for example, AI assistants or some kind of chatbots like Siri, Alexa, or even Cortana or Google Assistant, or even some kind of chat GPT applications like chat GPT or, for example, Google Gemini, Copilot, Microsoft Copilot, or some other kind of Grok AI or something. All right. So this will perform some kind of task where they have been actually trained on some kind of data. Fine. And let me tell you, the more data you give it, the more accurate, the output will be. Fine. So it's not like that. Like, for example, you train using some kind of data and you come to a conclusion that my machine learning model is perfectly fine. No, it's not that one. See, no machine learning model will be 100% accurate, guys. But again, what we do here is we test it with different kinds of machine learning algorithms and we come to a conclusion as to which model is perfect here. So this is what we actually do in a machine learning kind of thing. So it's always all building some kind of model, training it, testing it consistently. All right, using different kinds of parameters and again different kinds of algorithms here. So this is what we do in a machine learning kind of case study. All right. So because see, now there could be multiple algorithms which can perform the same kind of task here. So for example, what I mean to say is, now you want to predict something. So I can use linear regression. I can only even use random forest regressor algorithm as well. All right. So again, I need to, I mean, like for example, I need to even come to a conclusion here. So which of my model is giving me better accuracy? So it's not that you got some kind of good accuracy with this kind of model and you simply say that my machine learning model is well. So who knows? I mean, so for example, again, sometimes what happens is now understand that your machine learning model might be working well with some kind of data that you're training it. But sometimes what happens is with unknown data, it might not work well here. All right. So that might be the case here. Fine. So that might also be the case here. So always all, you have to consistently test it and again come to a conclusion here. Fine. Now let me show you some kind of real-time example, guys. So what we do in a real world example. So this, I mean, I'll show you in two ways here. So one is a regression model and the other one is a classification model, which I'll show you on Azure Machine Learning Studio. All right. So this is Azure Machine Learning Studio. I'll show you this one. So what we do in a machine learning project here. Now I'll tell you the differences here. What is, I mean, so what are the difference between using this Python scikit-learn kind of machine learning library and what are the difference that you perform some kind of machine learning task on Azure cloud here. So what happens with both of the things here? Now, prior to cloud, right, we had worked with some kind of, different kinds of machine learning models using scikit-learn, Python scikit-learn. So scikit-learn is some kind of machine learning library in Python. So one of the machine learning library, scikit-learn. Fine. Now, what are this one? So let me explain you. Okay. So for example, here I'm trying to build a linear regression model for ad campaign sales here. So for some kind of ad campaign sales, I have some kind of data. I'll also show you what kind of data it is. Guys, I'm getting some kind of noise from your end. Please, I request all of you to mute, go on mute. All right. The dataset contains information on advertising campaign expenditure across different media types and the number of dollars generated in sales for the respective campaign. So first try to understand the problem statement here. So the dataset contains information on advertising campaign expenditure across different media types. So what are the media types we are having? We have TV, we have radio, we have social media, and again we have influencer. All right. So these are the different kinds of media types. I mean, a particular company is going on with some kind of ad campaign. And again, let's say, for example, you can see some kind of sales which have been generated using different kinds of, media types here. Now, let's say, for example, the goal is to assess the relationship between the radio advertising expenditure and sales values. Find how the sales is getting affected, either increasing or decreasing with expenditure in radio ad media type. Explain the results here. So a good machine learning engineer, so let me tell you, is a person who not only, like for example, derives the output here, but again, you also can explain well with different kinds of things here. Now, for example, so the first thing is what we'll be doing is we'll be actually importing this particular data into our model here. So I'm converting this to a data frame. So I'll tell you what is the data frame later. So when you join this kind of course, you'll come to know everything. So this is how your sample data looks like. So almost all I'm having 4,546 rows here and again 5 columns here. And what is the data that you can see? So I'm having TV and this figure tells you that the company has almost all invested $16,000 in this ad campaign in terms of TV advertisement. And regarding radio advertisement, it has invested this much amount. And again, using social media, it could be anything. So I'm not speaking about any particular platform here. So it could be any kind of thing here. And again, influencer, right? Influencer. So there could be some kind of big influencers or small influencers likewise. So you have mega and micro. And again, this is the amount of sales that has been generated with respect to each and every media type here. No, but we are interested to find out, let's say, for example, so what is this particular, like, for example, sales with respect to radio? So, I mean, see, what I mean to say is our goal is to find out if investing in radio sales is resulting in increased sales here. All right. So once again, I'll tell you my question. If investing in radio advertisement sales is resulting in increased sales or not. So this is what you have to find out. So that means, for example, if sales is increasing, right? I told you something here. you have some kind of positive correlation here. All right. So you have some kind of positive correlation because when the area increases, right, the price of the horse is also getting increased here. Similarly, so here also what we do, here a target variable is some kind of, can you tell me what is a target variable here in terms of, regression? So what is
You're
a
trying
target
to
variable?
you're trying to says
Yes. So this is sales here. Our target variable is a sales. So which is also called response variable or output variable, fine, or dependent variable as well. Now this is my input feature. I'm considering only one particular feature here. So radio, fine. Now what I'll do, so we will use the advertising expenditure that is radio as feature to predict the sales values. Before we make any predictions, we will need to create the feature and target array. So leave it this one. So first of all, I'm converting it into two-dimension kind of thing. Then later on, so we build some kind of linear regression model here. Now that we have created the feature and target arrays, let's train a linear regression model on all feature and target values. The goal is to assess the relationship between the feature and target values. Note, there is no need to split the data because here we are going with only one kind of column here, that is some kind of radio. So no need to some split the data here. So what we do in a machine learning model generally in real world scenarios, generally when you have lots of data with you, right? For example, let us consider you have some kind of, 50,000 records. All right, 50,000 records. Now, generally, what we do, so in a machine learning model, we actually split the data into train and test here. Train and test. So, train almost all we do 70 to 80% of the data, we take it here. And testing, so what we do here is we test the data after training our model, we test it. Okay, so if it is 70, right, the testing data will be 30% here. Okay, so 30 to, let's say, for example, 20%. Okay, so we can even say 20 to 30%. All right. Now, what we do here is, so for example, now, in statistics, you people know this one, right? So we have population, we have sample. All right. So what we do, using different statistical methods, we actually test using some kind of samples, right? So we take some kind of samples and we randomly split the samples and we test it here. All right. So here also we perform the same thing. So we either, we split the entire data set into 70-30 ratio or some kind of 80-20 ratio here. So for example, let us try to understand we are splitting the data into some kind of 80% here, all right? 80%. So that 80% of the data will be using that data to train our machine learning model. So this is how we actually do it. And the rest of the training, rest of the testing data will be there, right? So which is 20% here. Okay. So this training data, which is 80%. So when you use some kind of algorithm, you actually derive some kind of accuracy. So what is the accuracy that it is giving you? So again, what you do after you get some kind of good accuracy, right? What you do is you use some kind of testing data on that particular model here, and it has to give you the same kind of accuracy here. At least not same. It has to give you near about some kind of accuracy. Let's say, for example, in the training part, you got the accuracy as, let's say, for example, 80%. All right. Now, if you take the testing, like for example, data, right? If not 80%, at least it should be near to some kind of approximately some kind of 80, 78% or something. Then we say that our model is doing fine here. But again, we use different parameters here in order to test our accuracy and we come to a conclusion here. All right. So then now I'll tell you some kind of things here. So because here we do not require any kind of splitting the data here because I'm using only one particular variable, that is radio. All right. So what I do, forget about the code here. So anyways, we'll be learning, coming to know about the code here. So first of all, I'm instantiating some kind of linear regression model. I'm using linear regression model from the scikit-learn machine learning library. And again, what I'll do, I'll fit my training data and again testing data. So X and Y here. All right. Then I'll predict some kind of values here. See, I'll predicting some kind of values here. So with different values of XMN, so you got different kinds of things here. But again, so what I do, so from the above output, we see that the sales values for the first 5 predictions range from 95,000 US dollars to 290,000 US dollars here. Now, is this a right model or not? Let us try to visualize our model here. So when I go with visualization, right? So you get the data in this way. That means with increasing radio expenditure, right? So when the radio expenditure expenses are increasing, right? So the sales is also getting increased here. So with this one, we can come to a conclusion, right? So that is now with increased expenditure in radio media type, the sales would also consistently increase here or exponentially increase here. So that means both of them enjoy some kind of positive correlation. All right. So this is what we can conclude actually. So that means with radio type, I mean, like for example, with investment into radio type, right? So my sales is getting increased. Fine. So this is how we come to a conclusion actually. Now, but again, what I mean to say is, for example, here we are testing with only one particular input feature. So likewise, what we do in real world is we also try to test it using some other kind of features as well. And then finally come to a conclusion, which is the optimal feature with which your sales is increasing. For example, now what I mean to say is, so here you got see, 95, let's say for example. So if we calculate the R score, right, you get somewhere some kind of thing here. For example, I'll show you in the class. I mean, all right. So let's try to understand that with radio type. All right. So with radio, you almost all got, let's say, 75 percentage. All right. Then what are the other kind of input features we have? We have TV. Again, we have social media. We have influencer, right? So you need to also come to a conclusion about those kind of features as well. Fine. And finally, I mean, we can derive some kind of output that, I mean, so due to some particular optimal feature, our sales is getting exponentially increasing here. So that's how we can conclude to that particular, I mean, advertise or ad company that if you invest more number, let's say, for example, let me else show you in this way otherwise. So, for example, we do have different types of things here. TV, social media, and influencer. Let me also tell you something. Now with TV, let's say we got almost all 80% accuracy. And again, social media. All right. Social media, we almost all got 85% accuracy. All right. And again, with influencer, you almost all got 78% accuracy. All right. Now, can you tell me which is the optimal feature here? Social media, right? Yes, by looking at the accuracy, you can come to a conclusion it is social media. Fine. All right. So now what you can tell to your that retail or ad company, what you can conclude here, what you can suggest him. You need to also give him suggestion, guys, because as I told you, right, you people are not any developers here. You people are the solution providers. All right. So now what kind of suggestion you will give him? You need to tell him that, boss, if you invest heavily into social media kind of media type, then your sales will exponentially increased actually. Okay, so this is what you need to come to a conclusion. So this is what we finally, I mean, derive some kind of machine learning kind of model here. So then we can say our machine learning model is perfectly fine and it is accurately predicting some kind of figures here. Understood, everyone? So this is one kind of case study. So this is a linear regression. All right. Then let us try to understand about the classification model. Yes. Classification model. So I can't show you each and every step here because it requires a lot of time in order to, because in machine learning in Azure cloud, what happens is, first of all, you need to create a workspace, which will take some kind of time. And again, after that, you need to go with a VM, that is some kind of virtual machine in order to run your machine learning models here. So I already done that one. So let me show you some kind of models here. So let me show you some kind of case studies. See, let me explain you some kind of thing. This is some kind of score, accuracy score here. AUC weighted, you able to see, right? So this is some kind of accuracy score here. Now, from this figure, right? So what you can do, you can come to a conclusion. So which is some kind of machine learning model. Now here, what happened is, if you look at this case study, right? Now, as I told you, there are multiple regression machine learning models here. So I'm using only linear regression. But who knows? I mean, so with random forest regressor method, right? So some other kind of machine learning model. I can even get a better accuracy. So, but again, here what happens is everything we have to manually type, and again, we have to manually check each and everything. But on machine learning, so that is on Azure Cloud Machine Learning, right? The machine learning, automated machine learning kind of, ML models will, do the job for you. So it is saying that with this kind of model, right? So with this kind of standard scalar wrapper and again XGBoost classifier, so it is able to classify, about 94.67 accuracy with the accuracy of 94.67. So likewise, what you have to do is you have to find out which is the most kind of accuracy that you got here. So is that you got any kind of accuracy more than this one? You can find out from here. And again, the model also after completing all the, like for example, iterations, right? So what it will do, it will even suggest you which is the optimal model here. So with which model you can go. All right. So this is what happens in a cloud machine learning kind of case study. Fine. Otherwise, what you have to do is in a Python scikit-learn, right? You can perform all these kind of things here, but again, you have to perform it with different machine learning models. You have to test it randomly. You have to come to a conclusion, and again, you have to, optimal. That means you have to come to some kind of optimal pattern here. But again, it will do the job for you here. So this is what is cloud machine learning kind of models, whether you go with Azure or whether you go with AWS or whatever it is. Okay. So how to do it, we'll be learning in our sessions here. Fine. So you see it is still running. My machine learning model is still running actually. All right. So it will, what it will do, it will randomly sample different amounts of data. Fine. And then it will try to test it with the different data points here. Then it will come to some kind of conclusion. So out of 100% accuracy, so the model with this particular model, you got almost all 94.456 here. All right. So likewise, if you look at this, so I think there can be some kind of models as well. So let us look at this. See here you are getting only 84, 85 something, 91. Fine. But again, here, so here if you look at, right, so it is almost all giving you 94.64. All right. So this is some kind of optimal 94.59 here. Okay. So, but it is 94.67 here. All right. So I can say this particular model is some kind of accurate model and not accurate, but again, I can say out of all these models, right? So this is the best classification model I can tell you. Fine. But let me tell you something, guys. In order to figure it out, which is an accurate model, right? You also need to know how to set it up manually. So that is why you need to learn all these things here. So how this stuff works behind the doors here, you need to learn the concepts here. So that is why you require some kind of, statistics here. And again, you require the concepts of some kind of Python programming and some kind of libraries in order to figure out which is an optimal model. So there are some kind of metrics. We also call them as metrics here. So metrics is some kind of, conclusion or evaluation kind of thing. Evaluation methods. I can call them as evaluation methods here. So what will you evaluate here is you will evaluate the kind of machine learning model with a better accuracy. So that those are called as metrics here. So for classification models, we have certain accuracy, and for again some kind of regression methods, we have some other kind of accuracies here. So we test it using different accuracy methods here, and we come to a conclusion. Fine. So this is what we try to do in a machine learning kind of models, guys. So I hope you got some kind of better understanding about a machine learning. So finally, see, so one thing you have to note it down is in a supervised machine learning model, you know your target output. So what is your target output? And according to the, like for example, kind of target, right? So for example, if it is a number, you can use regression. And if it is any kind of category in your data, right, then you go with classification model. So this is how you need to identify whether I have to go with regression or whether I have to go with the classification. Now in unsupervised machine learning model, right, you do not know what is your target variable here. So what you have to do, your machine learning model has to identify the patterns in the data and it has to tell you such kind of information here. Fine. So finally, so what are the different kinds of, examples which we actually perform using different kinds of machine learning models is in supervised learning models. So they actually learn by examples here. That means examples in the sense different data patterns here. So when it comes to the case of classification, I mean, probably these kind of machine learning models are used in real world in disease detection. So in healthcare, kind of disease prediction or something, and email spam detection here. So for example, I told you yesterday. So when the Gmail works on this kind of case study or this kind of machine learning model, so the kind of keywords that particular email is containing, so it will easily classify it as some kind of genuine mail or some kind of spam mail. Image classification. So given some kind of input features, like for example, years, notes or something, so it can easily find out which kind of object it is. Bank loan prediction. So whether depending upon the previous, like for example, loan history of a particular person, right, or customer, right? So we can predict whether that we can even classify whether he's likely to get some kind of loan or not here. So yes or no. Fine. So classification will consist of some kind of target output in such a way, so which is into categories, yes or no, okay, or positive, negative, this kind of things here. And again, when it is the case of regression, right, your output will be some kind of number format here. So it could be heavily employed in some kind of house price prediction, like just now I've shown you some kind of case study, right? So, I mean, the ad campaign prediction. That is some kind of real-time case study, guys, we are doing in our ongoing batch. And again, house price prediction and again, stock price prediction here. Fine. And again, if it is unsupervised machine learning model, so we actually, the machine learning model tries to identify the patterns and the data on its own here. So, I mean, we'll be using in clustering. So one such kind of common case study is clustering. So which is heavily employed into search engines, face recognition, targeted marketing, recommendation systems. All right. So product recommendations, all these are some kind of unsupervised learning mechanisms here. And again, we do also have some other kind of unsupervised learning called as association rule mining. So we'll figure out the odd ones here. So market basket analysis, medical diagnosis and census data. So we'll discuss it later in our unsupervised when we start with this kind of learning. And reinforcement learning, as I told you, self-driving car, gaming AI, and again, some kind of robot navigation here. So these are the different types of machine learning models. Now, based upon this one, right? So for example, let us try to even understand what is generative AI and what is the relationship between this different kinds of AI here. So we have artificial intelligence, we have some kind of machine learning, and again, we have deep learning and something. All right. So let us try to understand this one. Now, what is this one? So what is AI? So as I told you, AI mimics human intelligence here. All right. So AI involves techniques that equip computers to emulate human behavior, enable them to learn, make decisions, recognize patterns, and solve complex problems in a manner akin to human intelligence here. So what we do, so I mean, artificial intelligence is some kind of, case where it tries to mimic human intelligence here in order to solve different problems here. And machine learning is a subset of ML. So artificial intelligence use. All right. And deep learning is some kind of subset of machine learning. So where, it is used to, and figure out some kind of complex data patterns. For example, I want to find out which is a cat and which is a dog here. My machine learning model has to identify that one. And even if you look at the case of Tesla car also, Tesla car, so it has to identify which is some kind of moving object here. So moving object, is it a human or is it any kind of machine? That means any kind of automobile. So whether it could be some kind of car or it could be some kind of truck or something. So when it navigates on the road here. All right. So such kind of complex problems we actually perform using deep learning here. And generative AI. Generative AI is some kind of subset of deep learning, so that generates content like text, images, or code based on provided input. Trained on vast data sets, these models detect patterns and create outputs without explicit instruction using the mix of supervised and unsupervised learning. So what happens in generative AI is these models are already trained actually. So these models are already trained here. So they are pre-trained here. Fine. And we are using these models in order to, figure out some kind of thing. So in order to generate some kind of user-defined content here, it could be text, or it could be some kind of image, or it could be, yesterday I've shown you, right? So, tell me about some kind of Python code where I can add two numbers here. I've shown you that one. All right. So it is automatically, it is giving me some kind of result here, some kind of Python code. So likewise, these models are already trained on some kind of predefined supervised and unsupervised kind of learning models here. Fine. And they can give you some kind of data, user-defined data here. So this is what you need to understand, guys, finally. So as a final note, I'll tell you some kind of things, some important points I'll tell you. Now, what you can understand with the different kinds of this one, AI or ML or some other kind of things here. So whether it is data science or whether it is AI or whether it is deep learning or machine learning, whatever it is, I'll tell you a few points here. So AI was ML was DL, that is deep learning. So was data science here. Now basically AI is something so which mimics human intelligence here. Okay, human thought or human intelligence. Fine. Human thought or intelligence. So for example, we have different AI kind of machines or devices here. So popularly, let's say for example, we have IBM Watson. All right. So if you even search here, what are the popular AI, kind of things, popular AI tools here. All right. So for example, you see there are different kinds of things here. All right. So you get different kinds of, tools here. So what are the popular AI tools or what? So each and every tool is designed on certain aspect here. Fine. And again, now the other things is, so what is machine learning? Machine learning is some kind of subset of AI. All right. So learns, which learns from the data. Okay. The more you train the machine learning model on some kind of data, the better accuracy it will give you. All right. So more data it gets trained on, the better the accuracy. All right. So that is machine learning model. Now, what is deep learning? Deep learning, as I told you, it is a subset, subset of ML. All right. So which is used to perform complex data features. All right. So for example, let's say I can give you some kind of things as image recognition. Image recognition. So for example, speech. All right. And again, audio. And again, video, something. All right. So especially in these kind of cases, we use deep learning here. And again, what is data science? Data science here, it is used to extract meaningful, meaningful insights from the data. All right. So by using exploratory data analysis, by using some kind of tools and techniques like exploratory data analysis or some kind of statistical methods, and again some kind of machine learning models here. All right. So it is used to identify. Later on, we can even, like for example, visualize the data as well. All right. Now, one thing I can tell you is now what is the relationship between overall these kind of concepts is, and now entire thing is AI. But again, in order to solve different business problems, right, we use different techniques here. That is what you have to understand. So don't think that AI is completely different here, and again, machine learning is completely different. Machine learning is part of AI. Fine. And depending upon your problem statement, right, you use one kind of technique here. Fine. So, for example, now AI, if you consider it as an overall goal, right? So, for example, AI, if you can consider it as overall goal, right? So, what is ML then? What is ML? You can understand. So, it's AI's learning method. All right, it's AI's learning method here. So if you understand it as overall goal here, so AI's learning method is ML here. So that means ML is some kind of subset of AI. So AI uses ML, that is machine learning models, in order to understand the data. So this is what you have to identify. This is what you have to understand it here. All right. Then deep learning is a specialized ML for complex data patterns. All right, complex data patterns. Now, for example, now what do you mean by complex data patterns in the sense? Let me even explain you in this way. Now, if I give you some kind of data in a file format, you can easily identify the data patterns will be in the format of some kind of numbers or text here. All right. So, but again, if I give you some kind of data patterns, right? So, for example, I give you some kind of image here. So is image and again the tabular data, whatever you have, both are the same thing? No, right? Image is something different. And again, let's say, for example, your data which resides in some kind of text and numbers format is different, right? Now, if I have text and numbers format, so it is very simple me to identify the patterns in the data. But if it is some kind of complex data pattern like an image, I want to identify what is a cat and what is a dog here. Now, both have different features, right? So, for example, dog has, the ear size is more actually, for example, compared to, cat ear. Fine. So, likewise, so again, you have, the tails will be different here, the legs will be different here. All right. The size of the dog will be different here, and size of the cat will also be different here. So, likewise, what I mean to say is you need to, give it different features here for your machine learning model here. So that is why you can understand it is a specialized ML for complex data patterns here. And again, what is data science then? Data science, you can understand data science is some kind of technique or a way, for analytics technique. All right. So for performing data pre-processing and data pre-processing for AI and ML. Now, what is this one? It's an analytics technique for performing data pre-processing for AI and ML. What is data pre-processing here? Now, data pre-processing is something, data, data pre-processing is something where you, clean your data set properly. For example, data cleaning is one kind of concept here. And again, transformations is one kind of concept here. Now, yesterday I told you one thing. Now, even if you have zeros in your data, right? So accuracy will fall down. So what we do, we try to replace that zero with the mean of that particular column here. Fine. So likewise, what you do, you properly clean your data and properly transform your data. So that is very, very important in order for a better accurate model here. So all those kind of transformation techniques, all those different kinds of analytics techniques here. All right. So whether you're performing some kind of statistical models, you're applying some kind of statistical procedures on the data. For example, mean, median, mode. So what are the average price here? Yesterday I told you with some kind of project here, right? So what are the minimum price here? What are the maximum price of the order here? What are the average price of the order here? So all those kind of analytics techniques, right? So data science is required for, for pre-processing the data for AI and ML here. So when this is done properly, right? Then what you can do, you can use some kind of machine learning model in order to come up with some kind of conclusion on the data here. All right. So this is the interconnection or some kind of relationship between the data here. So data science, I can say it supplies quality data for your ML models here. And again, what is machine learning here? It enables data learning here. All right. And AI is some kind of foundation for different machines or different models here. And again, deep learning enhances pattern recognition. Pattern recognition. That means what is the eye size of your cat and what are the eye size of your dog here and what are the ear size of your dog and compared to cat here. So this is all pattern recognition here. Fine. So finally, data science feeds data to ML. Okay, so you can also come to a conclusion, right? It feeds data to a ML model. All right. And ML uses DL for analysis. I can even tell in this way. ML uses deep learning for complex data analysis. All right. And leverages, for example, AI leverages all those above techniques for different operations. Now, for example, what I mean to say is, now let's say you're designing some kind of chatbot similar to ChatGPT. All right, similar to ChatGPT. Now, first of all, you need to have vast amounts of data with you, right? Yes. So all the publicly available data or all the formatted data, clean data, everything. Okay. So that is what data science provides you with. Okay. So then you come up with some kind of machine learning models, whether it is complex machine learning or whatever it is, you train that particular data using different models here. Then finally, you design your chatbot here with that kind of data. So this is an overall picture of your AI, machine learning, deep learning, or data science. Fine. So now I hope you got a better understanding of all these kind of things here. All right. So now questions, please. So have you understood what we at least perform in a machine learning models? What we do here? actually. And again, how do you come to a conclusion? And again, so what do you suggest to some kind of end users here? You need to suggest something. Yesterday also I've shown you something. So what is that recommendation you make actually to the food, app actually? And again, today I've shown you some kind of machine learning model where we use regression in order to identify which is the optimal feature here. Fine. Now questions, please.
Rashmi,
So
I've got one.
yes.
Based on your explanation on how you've broken down AI, machine learning, deep learning, and data analysis, do I need to be like an effective data analyst to be able to um, be like in order to like be a machine learning engineer? Or in a real life project, will I be working like with data analysts who provides the data for me to be able to like use machine learning to make my predictions? How does it
Fine.
work in a real life project?
So fine, let me explain you something. See, in our course, I've designed the course in such a way that so right from the scratch, you'll be learning all the things here. So for example, whether you want to become a machine learning engineer, so you want to work as
You
a
can
data
share the
scientist.
course content once, Vamshi.
Yes,
Maybe
yes.
on the screen
Lord.
share, please.
Yes, yes, I'll do that one. I think we have this one. So let me explain you with the course content here. So how I designed this course content, so because see, now a lot of you people can be from different backgrounds here, different academic backgrounds, I mean to say. All right. So now it's a basic thing that, so when you want to design any kind of model or when you want to perform any EDA part, that is exploratory data analysis or write some kind of code. So see, you require some kind of knowledge on some kind of programming language here. So go with Python as our programming language. And let me tell you guys, Python is very simple to learn. It's easier to understand. It's not like unlike some other kind of programming languages like Java or any other kind of programming language where you need to write lengthy lines of code. So trust me, it is very simple to learn. Fine. So here I'll train you in Python programming. And again, so we'll also discuss what are the things that are required for performing our data science case studies and again, machine learning. So once we complete this data science part, right? So the data analysis part here for data science, we move on to the statistics part here. So I told you different models here now. Okay, so how you need to come to a conclusion here. So with what parameters will be testing your data. So for all those kind of things, we require some kind of statistical part here. Fine. So whether it is univariate analysis, bivariate analysis, yesterday we have looked at some different project here. So different plots here. So whether it could be some kind of histogram or some kind of bar plot or some kind of pie chart or some kind of box plot or something. Fine. So in the same way, let me tell you, we'll be learning all these kind of techniques here in statistics. And again, how you can, given some kind of data set to you, how you need to proceed here, how you need to start with some kind of analysis here. So step-by-step procedure, you will be learning here. Fine. After this, we'll be moving on to the machine learning part. So once you're thorough with this part, right, statistics and EDA, then you can dive into machine learning. Okay, so you can be very confident on how to derive some kind of output and again, how to come to a conclusion here. Fine. So, see, step by step, you're learning here. It's not that directly you're moving on to machine learning here. So first of all, you're trying to learn some kind of programming part here, then data analysis part here. So using some kind of Python libraries. And again, then the statistics and EDA part, which will help you to uncover the things in machine learning. Fine. Then you'll be learning different machine learning techniques and different machine learning algorithms here. So both supervised and unsupervised kind of learning. And again, this is what you'll be doing it in real world scenarios, guys. So this would be your job here tomorrow. Fine. So once you complete this one, right? So I'll tell you a deep learning technique, then we'll move on to the Azure part here. So on Azure, how you can deploy some kind of machine learning, models here. So how you can train a classification model, how you can come up with a regression model. So how you can cluster some kind of data. And again, so likewise, how you can perform some kind of NLP task or some other kind of task here. So I've given you different hands-on real-time project scenarios here on Azure cloud. So once you're done with this one, right, let me tell you, you'll be very confident enough to crack interviews here because you know both the things here. You know how to work with Python scikit-learn. You also know how to work with cloud machine learning models here. So when you have both of these tools, right, obviously you can definitely stand out in the market. Fine. Apart from this one, after learning this, you'll be also, I mean, parallelly, you'll be also learning what is generative AI. So how you can even, use generative AI models here on Azure Cloud here. Fine. So you'll also be learning this one. So once you get to know this one, right? So again, with the real-time projects which we'll be solving, right? You'll be really getting some kind of good hands-on on the different kinds of models or different kinds of, things here. Fine. So then you can be very confident enough to attend different interviews here. Right. So post course as well. So what I've done is I've designed the course in such a way. So I'll even explain you what are the interview questions they'll be asking you. And again, with the different real-time scenarios as well. And again, it also has you in case if you really want to write some kind of certifications here. And of course, the major thing is how you can design your portfolio. That means how you can design your CVs here. So what kind of portfolio projects you need to build up here. And again, how do you need to stand out in the job market? So I'll also tell you the tips and techniques in order to, showcase your profile on LinkedIn. Fine. So these are the ways that you can learn and master this course. And again, you can be very confident enough to, step into this kind of AI world, AI jobs here.
Okay, thank you. And sorry, I don't really mean to like take much time. I had a follow-up question. Now, bearing in mind that this course is strictly focused on Azure cloud machine learning models, and you've got like different, I don't know, you've got like the AWS one, probably ServiceNow also offers like some sort of like AI platform. Will I be correct to think that once I learn Azure, I'll be comfortable in AWS and any other AI platform in a real life project? If for any reason, probably like a company doesn't use Azure.
No, no, no. Let me tell you, see, in real world situations or in real world jobs here, what happens is now they'll be asking you if you know ML or AI, whatever the job role you're looking for that, right? So if you know those concepts or not, they'll test you in that one. And again, the choice of your platform is it is up to you. So, for example, now you might be knowing Azure. So, some kind of professional, so some kind of guy, he might be working, on AWS platform here. So, they'll give the choice unto you. So, it's not that, so the job can be performed only with AWS or only with Azure. So, they'll be giving the choice of cloud models to you. So, you can work with Azure or you, if you're told you know AWS well, so you can even work with AWS as well. So, that's up to you guys. Fine.
Okay, thank you so much. Thanks for the clarity.
See,
Hi,
yes, sorry. Yeah, please go on.
that's okay, Lakshmi. I wanted to ask you, why did you choose Azure instead of AWS? Because I see the prospects of jobs mostly on the AWS side.
Let me tell you, see, Azure is offering you multiple services just similar to AWS as well. But again, the cost of implementation here is very cheaper compared to AWS. And now the momentum is slowly picking onto Azure here. So very soon you can see in the ML kind of jobs here. So more number of jobs might be onto Azure very slowly. Okay. So right now, if you look at the other kind of jobs, like if you take some kind of data engineering or some other kind of job roles, right? So jobs are more onto Azure platform. Fine. So here, let me tell you guys one thing. See, irrespective of the cloud, you can work with any kind of cloud here. So they'll not ask you that if you know only AWS, you can step into this kind of job role. You can work on any kind of cloud here. So cloud is some kind of medium on where you design and test your models and deploy your models here. That's it. So you need to know the, like stuff, right? Okay. So for example, you need to know how you can come to a conclusion about some kind of machine learning model. You need to, like for example, go with different metrics here. So you need to be confident enough on those kind of areas here, not any kind of clouds here. So you can even see if you want to work with AWS, that's up to you. So that is what I'm telling you. So cloud is not a mandatory kind of thing. So though you find a lot of jobs on these any kind of clouds here.
On top of Vamshi, I think we have the article from the Forbes as well, how why the Azure is going to be
Yeah,
leader
yeah, yeah.
by
Let me even show you that.
2026.
Yes.
Yeah, that because we do the market research as well. We have
Yes.
done AWS training programs as well, but now we switched everything to Azure, Azure DevOps, Azure Data Engineer, Azure AI/ML. Uh, and that I think from the Forbes, I just messaged the link in the group as yeah, that's the link I think. Yeah.
This one. See, my Microsoft Azure could take the cloud lead from Amazon AWS by 2026. So you can see this article was published on Forbes here. All right. So I mean, see, there are different reasons for this one. All right. So now Microsoft is betting very huge into this AI field, right? And again, when they join hands with this, I mean, Open AI, so they have rolled out even some kind of product and Chat GPT and some other kind of things here. So they're betting huge onto this kind of field here. And yes, of course, I mean, so you can even what do you mean by this one is we can even get a lot of jobs onto this particular platform as well in the near future. Fine.
Sounds good. I have a follow-up question. Sorry. Within this 3 or 4 months, whatever the course length is, what is the cost we're looking at while using Azure, roughly?
Cost in the sense, can you be specific about that?
So obviously, we'll be training us on Azure cloud, right? So there is some cost
Yes.
involved while we're,
Yes.
like signing up there. So roughly, what is the cost we're looking at for this training?
Now, if it is a free trial, it is okay for you. Fine. But if it is any kind of, I mean, license that is or pay as you go kind of model, if you do not have any kind of free trial account, right? So let me tell you, hardly it costs you somewhere around 50 to $100 a year, not more than that one in deploying all these kind of models here. But let me tell you, not even that one. I mean, less than 50, $60. I mean, so the price varies actually.
That's with
I
a free trial, you said, right? Or
Not with trial, pay as you go kind
okay,
of model,
pay
I'm
as well.
telling you.
But
Yeah.
we can use free trial just for this learning
Yes,
purposes.
yes, of course. You can still
Okay,
use it.
cool. Okay, thanks.
even if you're
Again,
paying Sadiq, I think the important trick is like the moment we stop using it, I think we need to stop the services. Otherwise, they will charge like anything.
yes, of course.
Mm,
Yeah.
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 So I'll also show you how you can remove those kind of services even. But again, let me tell you. So initially we'll be starting off with Python and so kind of things, right? So I won't tell you to install or open your account, I mean Azure account. So once we move on to the Azure machine learning part, then I'll instruct you to create your Azure accounts here. So you can be safe because I mean, see, this Azure and again AWS comes up with some kind of validity, right? Free trial accounts. So it's better those, I mean, create those kind of accounts when we really need them. All right. So need not worry about that one. So I'll guide you step by step on how to, I mean, work on those kind of accounts and again how you can leverage a very cheaper cost here.
Yep, thanks.
Yes, I think there are even certain other questions as well. So let me take them.
I got one question.
Yes, please go on.
How proficient do we need to be in Python, or do we need to learn programming? Or like if it's harder for people who haven't done it before, do we need to get
Let me
into it?
tell you. Intermediate knowledge is required, but again, as I told you, we'll be learning from scratch. So even if you do not know Python programming, need not worry. I'll be making you learn from scratch here. All right. So we require intermediate knowledge in Python. We do not require any expertise in Python, so we do not need that one. Fine. So
Gotcha.
don't worry about that. So I'll make you train on this Python platform.
Yeah.
But the important thing, Murtaz, not only to you, to all of you, including myself, is we need to have that passion towards this technology and that zeal and that research kind of an like a passion towards that one. Otherwise, we may feel, oh, this is too much or feeling bored. So you have to keep good amount of efforts to learn. Definitely, I mean, this is the only way to stand out in the market, in this competitive market nowadays. If you're learning any basic skill, you have another 100,000 people along with you for the competing. Yeah. If you are learning something like this, which is really hotcake in the market, and that will just make us stand out. Thank you,
Yeah.
Mumtaz. Okay. Sorry, Vamshi, you can go ahead. I think Niran
Yeah,
has
yeah.
asked a question. Yeah, please.
Yes. Yes. Any other questions, guys?
Niran has asked in the chat. I don't know if you answered
Yeah,
that.
yeah, yes, of course, of course. Yeah. So, um, quick quest
Yeah.
for the ML, do they only understand numerical values and not alphabets, especially in the data classification? No, let me tell you, in regression, we have numerical values. In classification, we have categorical values, Niran. And the other question is, so how did you predict the values, Niran? So let me tell you, there are some kind of models, okay, so which we use, and again, metrics which we come to a conclusion. All right. So we'll be learning once we dive deeper into machine learning, right? So in the course, you will be learning everything there. And again, so what are the various models of ML apart from regression and which is mostly used? So let me tell you, in case of regression, linear regression is most widely used. And apart from linear regression, we have some other kind of regression methods like, random forest regressor. All right. So like, so we have some other kind of models as well. So what we do here is we also test them using those models as well. Fine. Then what are the tools used for machine learning? So machine learning here I'll be making you trained on Python scikit-learn. So scikit-learn is one kind of machine learning library in Python. Fine. Then again, we'll also be learning on Azure Machine Learning Studio. So cloud machine learning, Azure Cloud Machine Learning. And again, so what is the timeline for each module? So Niran, let me tell you, there is no particular time for each and every module. So once you feel comfortable with that particular module, we'll be moving on to the other one. So there is no such kind of time frame I'm putting onto each and every module here. But what I'll assure you is that, like for example, once you are confident enough in that particular model, right? So we can move on to the other kind of things here. So that is what our focus will be on to. Are we starting from day one, Monday? Yes, Murtaza. Yes. So what are the timings of classes and let me tell you. So the same timings and estimated time for this particular course will be about 3 months. Even if it requires any additional days, we'll also, extending our course as well. And again, so I'm not from a coding background or tech background. So zero in programming. Currently, not employed. So basically, let me tell you guys, need not worry. As I told you, everything I'll teach you from scratch here. Now, let me tell you some of the basic things we have already learned in our childhood days here. So whether it is basic statistics or some kind of basic math here. So, but again, you'll be learning those kind of things here and how you can work in machine learning or something. I'll make you learn them. Okay. Need not worry, even if you're from non-IT background or even if you do not know Python or any kind of programming here. So, you can be rest assured here. So is 3 months actually sufficient? So let me tell you, 3 months is the stipulated time. So, but the have like for example for this course completion. But as I told you, if it requires some additional days, so we'll also extend here. So need not worry. Fine. All right. So any other questions? So how did you felt about this kind of example or something? So have you at least understood what we do in machine learning, what is data science and what is something? Have you got, I hope you at least got some kind of idea, right?
Yes, the warm up definitely. Yes, from my side, I'm also a new learner here. I'm yeah open for the feedback team. So some of you messaged me that is this the actual class we are already doing? No, it's like before we play the match, before we really practice well, we need to have kind of a warm up. Yeah, before we go for a jogging, we do some basic exercise. So these two classes are like that one. They're like preparatory and a bit of warm up to get the feel of the class, to get the feel of the Vamshi, and to let you know that this is completely real. There is no scam here. That's the main objective of yesterday's and today's session. So we all will be collaborating from Monday, the same time, 1 hour, 30 minutes, and we go for 3 months or maybe over 3 months. So Vamshi is not that kind of a person who just exactly stop on the last day. So it may take 1 week or maybe 10 days extra. That's completely okay. But we are here to support you until you succeed. Another good thing is some of you are concerned that will I be confident? Can I learn this in 3 months? No issues at all. If you're not really confident in 3 months of time, we do these batches regularly. And the next batch, you can absolutely join free of cost, no charges at all. Which means to say that you can join our trainings 2 times or 3 times. You don't need to pay not even $1 not even $1. So whatever the payment that you're paying is like a lifetime boarding pass. So you can join our classes any number of times. Not only this training, all my trainings, the data engineering one she's doing, the Azure DevOps, or even the cybersecurity, or my one Scrum Master product owner, all our trainings, just knock the door. My doors are widely open for you to learn. Okay, cool. Any final questions? Young investors, oh yeah, thanks for that one. Oh, hope you are not here promoting your thing. So I appreciate the fact that okay, you build that AI. That's a great to know. And if you want to enhance this AI by learning this one, that's very good. Yeah, good to know that one. Enoch is saying, but please reduce your speed. Okay, yeah, it will be
Yeah,
too. Vamshi is trying
fine.
to push a lot of things in this short amount of time. This is a high level thing, right? Trying to cover a lot of things. But from Monday, things will be at a slower pace. Enoch, you will be having the training and a hands-on activity like that every day, 1 hour, 15 minutes, and we go like that. Any final questions? If any of you are yet to register, you still have time tomorrow, day after tomorrow. So please message me on my WhatsApp number. You have my WhatsApp number. So join our Telegram group. Lot of postings and free webinars we conduct like this. Yeah. Anyone? Any final question? Final check?
Sorry,
I will
just
be
one
sharing
last
this.
one.
Yes,
Just
Innocent,
one
please
last
go ahead, sir.
just one last one for me. Because of work commitments, can we kindly make these trainings probably like if we say 1 hour 15 minutes, probably have a hard stop for I don't know, for the time frame within which the call is scheduled are supposed to go in over time.
No, it won't go too much of overtime. So yesterday and today, this is exceptional. This is like a free webinar and demo is trying to cover more. So, but
Yeah.
in the real class, actually 1 hour, 15 minutes, maybe with the question and answers, 5-10 minutes here and there, but not definitely beyond 1 hour 30 minutes.
Okay, thank you.
Okay, Vamshi, please make a note of it. So let us not try
Yes,
to
yes.
exceed that
Sure,
one.
sure.
Yeah, definitely. Yes. Even accidentally you miss like a 10 minutes here and there, you always have the live class recording as a backup. So you can watch, you always ask the questions in the WhatsApp group, or you can directly call Vamshi as well. I will share his personal number. Praneeth, nice explanation. Thank you very much, Praneeth, for the feedback. Any other questions? Final check. 1, 2, 3. All good. Thank you very much, Vamshi, for your valuable
Thank you.
time. Yep. Thank you all for your participation. It means a lot to us. Hope you all got value. Thank you. Bye-bye.
Thank you, everyone. Thank you, guys.
See you on Monday.
Yeah.
You can stop the recording, Vamshi.